Hi everyone, my name is Joe and I'm a geographer, and I want to give you an update on some of the more relevant and pertinent issues that are going on around the coronavirus epidemic, or pandemic really. So what I want to do is I want to show you a little website that helps you play with the numbers, these assumptions that you can make about how much people are distancing, what the infection rate might be, and when the day when the virus started was. I'll show you a little bit of that and show you how much of a difference it makes what assumptions you put into the models. And this also will help explain why some places are seeing a really severe outbreak and other places are not. So if you go to Florida, and Floridians are wondering, well, why aren't we having as many cases as New York, for example? So we must be doing something right, or maybe New York is doing something wrong. Maybe we shouldn't be social distancing. Maybe social distancing isn't working. It's not working in New York. And look, the cases are better here. Why not just go ahead and open up again? Well, there's a reason for that, and I want to show you that. So let's talk about the consequences of letting up on this pandemic. Remember flattening the curve or to delay the outbreak peak so that hospitals and other infrastructure would have less of a burden, and there'd be a less deaths, less health impacts, and so forth. The way that we were going to get that accomplished was by social distancing measures. Now some states are opening up, some are planning to open, and if you look at this map, what you see is that partial reopenings already happened, and some places are just about to open partially as well. I want to look at Georgia and Florida here, focus in on them, and see what we can find out about that. So first, Georgia. You can see here that the order began to shut down in around April 1st, and if you follow this line, what you find is that it continues to rise a little bit for a few weeks, 2 to 3 weeks, before it begins to taper off a little. So it rises and it flattens out essentially, and it's just now starting to maybe taper down. So there really hasn't been a lot of time for the cases to go back down, and that's a key thing to remember. What is Georgia doing? They're opening up outdoor recreation, entertainment, things like bowling alleys and theaters, private and social clubs, retail and beauty stores, hair salons, and so forth, and then food and drink restaurants. In Florida, the cases began early on as well, and if you compare it, here's about the beginning of March here, when you start to see a little bit of a rise. If you compare it to Georgia, you start to see about the same thing there too, around the same period. In Florida, the orders to close down, do social distancing, began right around the same time as Georgia did. Florida had a little bit more success, and while the cases rose for another week, eventually it started to taper down and slowly begin to go down as time went on. So the social distancing measures began here, and by about mid-April, you start to see a very slight decline, very, very gradual decline in the number of cases. Now Florida is planning to, and I think they're doing this today, opening up, allowing restaurants and retail stores. Look at this chart. This is from the 2009 H1N1. And there was a first wave. It tapered down, and another second wave came and was even worse, about twice as bad in terms of incidence than the first wave was. Pandemics tend to have wave patterns. It's not uncommon for this to happen, and they have a lot to do with how society responds. So now we're faced here, we're at this point with COVID, just at the peak of the first wave, and we're starting to see a little bit of a decline, and that has a lot to do with the social distancing in this case, and all the measures that were taken. which were massive and were really comprehensive. And really, we did a tremendous job getting the social distancing measures to work in most places. But what I want to talk about a little bit is something about the models themselves. How do we figure out how these models work? What do we need to think about? And first, we need to know when the outbreak started, the start date of the outbreak. We also need to know the initial number of cases that seeded the outbreak. Was this one person, 10 people, 100 people? That's critically important as well. Knowing the basic reproductive number, that is, how infectious this disease is, how many people will catch it from one person? Will one person give it to 2 people, to 4 people, and so on? And the most important thing of all here is the effective reproductive number. That has to do with how social distancing measures have lowered the basic reproductive number. I want to show you a model developed by the Dalla Lana School of Public Health in the University of Toronto. Now, this is showing us the epidemic growth based on these numbers I just went over. And you can see that with nothing being done, with a reproductive number of 2.3, that is 2.3 people getting sick for every one person, this is what would happen. There would be an exponential rise in cases. This blue line is what actually has happened, and it corresponds more to this orange line. And this orange line is assuming that the reproductive number was reduced to 1.5, like this line, that the curve is shaped differently. What probably happened was that the reproductive value lowered gradually. So it might have been higher here and started to taper down, so that by the time you get further and further into the future, the reproductive number is getting lower and lower and lower, and so that is essentially tempering or flattening the curve here. So this is where we're at right now. I want you to compare this to other scenarios. Let's change the outbreak start date first of all. Let's say rather than starting on 11/15, let's assume that the start date was December 31st. So about 6 weeks later, if that were to happen, the model would predict that the outbreak would start later, about 6 weeks later. So there's a relationship between the start of an outbreak down here, December 31st, and how long it takes for the numbers to build until you reach the exponential curve and it starts to rise. So that would not conform to what we've seen as actual cases. So we know by that this number is too high. This date is too high, I should say. Here's the thing, where this gap here between when the date started can make a huge difference as to this gap up here. The important thing here is to look at this orange line. See that? That orange line hardly has budged, has not increased yet. It's like the orange line across the whole period. And so if the outbreak starts a little bit later, let's say instead of starting here, it starts here, then this orange line is not going to show the disease manifest. Not yet. Does that make sense? So that we need to know exactly when the outbreak began to understand what is happening today. Now, this is the situation as it stands now with an RO of 2.3 reduced by 1.5 by social distancing measures. So rather than having this line, we have this line here. What if we change the initial number of cases from 1 to 40? Same start period, but all of a sudden you see that the line of time has shrunk quite a bit. By starting with a bigger seed, the epidemic does not need as long of a period to hit the curve. It can hit the curve a lot quicker, as it has here. And again, whether it's an RO or an R naught of 2.3 or one that's reduced by 1.5, you still are seeing a pretty significant epidemic going on here. Now let's take a look at this reproductive number. Right now it's assumed to be 1.5 and it looks like this. What if we bring it down to 1.2? Look at what happens to the curve. It goes way down. So if the effective reproductive number is brought down by social distancing to 1.2, then we would have seen something akin to this. We did not. This is what we saw. This is likely because we brought the reproductive number down gradually, and it took a while to get to the point where it was closer to 1. If the effective reproductive number is 1, then there is no epidemic. There's no spread whatsoever. That's the magic number. So what you're trying to do is get the epidemic down to 1 or below 1. If you can get it to below 1 and you have a certain percentage of people infected, that eventually it will be a negative effect and the number of people infected will begin to go down. Let's go back to 1.5. This is the baseline here where we think we're at. What happens if we go the other direction? What happens if the reproductive number increases to 1.7? Let's say we give up on social distancing just a little, right? The number begins to increase and all of a sudden you see these curves start to happen earlier and faster. And if we go up to 2, even further, the curve begins to go even faster. So this effective reproductive number here has everything to do with how much social distancing is happening in any given time. And this number fluctuates up and down depending on what society does, depending on what individuals do, what kind of laws, what kind of rules, what kind of measures are taken. For 200 years, public health science has tackled epidemics, infectious diseases, and it's brought the world to a place when something like this pandemic is extremely rare, whereas before they were very common. All of this knowledge, all of this study around infectious diseases and how they spread is not arbitrary. It's not somebody's guess. It's the accumulation of generations of scientists researching this stuff. And to say that scientists don't know what they're talking about or they're making lots of mistakes, that hasn't anything to do with their understanding of the mechanisms behind an infection or an infectious spread. That's pretty well established. What is uncertain is who the first patient was, how long it's been in the community, what the infection rate really is. There's a lot of things that need to be researched. And as new data comes in, those elements of the virus will change. And so the estimates will change and the models will change. Not only that, the models have to figure out how well societies will politically and culturally act to deal with this pandemic. So what steps are they taking? You can only project about how many deaths you're going to have if you know how many people are being exposed or not. And that's a huge uncertainty for these models. So what happens is you have to make assumptions about that as well. It's not that the models are wrong per se. The models are pretty accurate. It's just putting in the data, all of these assumptions that can make them swing one direction or another. But we do know very, very clearly that when people are close to other people who have an infectious disease, like a virus, that virus jumps from one person to the other. When people are far apart, that virus does not jump from one person to the other. That's the whole point of social distancing. So now people are saying that social distancing should not have happened because the infection, this disease is a lot less killer than people thought it was because of these antibody tests that they're doing. And that's a huge mistake. It's a very dangerous assumption to make. We don't know that. We don't know what the prevalency is. We just don't. We have some guesses. That's it. And if you go by the official cases, if you go by what we do know, the cases that we have measured, the death rate is pretty high. And it's likely to end up being somewhere maybe in the 1%, 2% range, perhaps. And that doesn't seem like much, but that translates to millions of dead in just the United States alone, because there's such so many people. Not to mention that this disease also has lasting effects on people who do recover. People are coming away with problems that may never go away or will take a long time to go away, life conditions. And so we know very little about this disease. So yes, everybody wants to open. Everyone wants to get their lives back. And this kind of creates an unconscious bias in people that they want to believe the good news and they do not want to believe the bad news. People want to believe the scientists and the experts that are telling them that this isn't as bad as it really is, that we should open up. But if you start to look at who these experts are, you most often find out that they're not really experts in epidemiology. They're not experts in viruses. They may be doctors. They even maybe have a PhD, but it's a specialized field with specialized knowledge. And really, we should only be listening to the people who have the correct knowledge on this subject. So I hope this was useful. And please share this video. Follow me if you want to learn more about this pandemic. And also I'll be starting to talk about other issues as well, like climate change and so forth in these videos. And thank you for watching, and I'll see you soon.